Hello, everyone, and welcome to our annual IEP workshop. Before we get started, I'd like to thank the Cal-Neva chapter of AFS for continuing to partner with us, the IT staff at CDFW for helping with the logistics of bringing you a completely remote workshop, and the planning committee for this year's workshop. As you can see, it takes a lot of people pitching in to pull these together. And thank you, Christine, for making sure that all 120 presenters and panelists had all the information they needed to make this a success. This year's workshop will be on a couple different Zoom platforms, but all the different links can be found at the beginning of our program that's posted on our website, including the links for the poster sessions in the evenings today and tomorrow. You'll notice that the poster sessions are earlier than usual, and that's because we normally plan for extra long breaks to promote mingling at our workshops. But in this completely remote format, we can make our days shorter. This year's theme is early career scientists. So you'll find a lot of nuggets in the program focused around continued growth that are really applicable to everyone. We hope to inspire some of our more seasoned scientists to do a little something extra in support of those who are starting their careers, and to give you newer folks a better understanding of what IEP is and the different roles of our member agencies. It's this sort of reaching up and down the career ladder and inside and out that holds the IEP community together and helps us to continue to grow and be stronger, keeping us relevant and effective. For those of you who registered for the mentor lunch, it will have a little different feel from the main program because it's using a Zoom meeting with breakout rooms where you can talk as though you're in a typical video meeting or web conference. And you can already access those through the links that were sent to you in an email previously. This is the first time we're trying to have the mentor lunch in a virtual platform, but we wanted to give people access to scientists that they wouldn't otherwise have access to. You'll be able to remotely meet and mingle with mentors, so you can pop in on multiple mentors or just hang out with the one that interests you the most. The poster sessions will be using a similar format, but you don't need to pre-register. It's simply going to be open to those who use the session links provided. If you aren't participating in the luncheon, I really encourage you to read the mentor bios, regardless of your career status. They include wise words on what these mentors have learned along the way, and I think you'll really enjoy them. Thank you to all the members who are paying it forward by volunteering for this, including the ones who didn't provide a picture. Another slight change this year is that our poster slam session also incorporates lightning talks, so you can get a ton of information in a short amount of time. It should be a lot of fun too. It usually is. On Thursday, we'll have concurrent sessions running, so there's a separate Zoom link for each of the rooms, and you can pop between the rooms at will, much like you were if we were in a meeting in person. As we embrace the use of social media, feel free to use this hashtag during the workshop. My last note on the program is that we want to acknowledge high-quality contributions to the workshop. So this year, we're holding separate votes for the best early career poster and the People's Choice presentation among all presenters at the workshop. So we encourage you to vote for your favorite poster and favorite oral presentation, and you can find the ballot on our annual website, the IEP website's annual workshop page. Okay, so now for the logistics. General participants will be muted with cameras off when they join, and presenters should only use their presenter links when presenting and should otherwise use the general audience links. We'll have a mix of live and recorded presentations, both with in-person events. See, I'm fumbling already, just like a real live person because I'm speaking to you live. If the speaker keeps to their time, session chairs will moderate questions from the Q&A box and raise hands with the remaining time. So you don't have to wait until the talk is over to submit your questions, but this year presenters will only respond verbally during their time slot. We're not typing responses this year because we want to make sure that everyone is able to focus on the materials being presented rather than getting distracted from the talks by messages flowing through the Q&A box or having questions from prior talks spilling over in and distracting the audience from later talks. This also enables the questions to be captured for the recordings. Presenters will be provided questions from the Q&A box after the workshop in case they want to follow up on any of the questions or comments received. If you use the raise hand feature, the session chair can call on you and will unmute your microphone for live questions. The general workshop sessions where authors have provided consent are all being recorded and will be posted to the IEP YouTube channel for viewing until June 30th. So please be patient with us as we ensure that the closed captioning makes sense before we post them. So as we're transitioning from a pandemic to an endemic, I decided to look back at my opening remarks from 2019. And I wanted to call your attention to some of the programmatic accomplishments that we should be really proud of. So back then, field operations, new technology, data, and reporting were at the top of our futures lists. So I thought I'd share these accomplishments through the lens of one of our biggest accomplishments, our website. So with COVID and COVID protocols, jumped ahead. The reliability of our field operations has always been a struggle, but through the leadership of our fleet resiliency team, we have greater communication and collaboration to help cover each other across agencies in times of need. One really great example of this is how Fish and Wildlife Service and CDFW joined forces to really integrate the Mossdale trawls. They had previously been performed separately, but now this provided us built-in backups for staffing and vessels, and also makes the methods that they use directly comparable, and the use of that data far less confusing. So with COVID and COVID protocols hampering our field operations, we've implemented written monthly updates for our surveys that you can find here on the website, along with additional information about the surveys, including our views from the water blog, or you can follow some of our field staff on Twitter and use the handle @IEP_on_the_water. We've also implemented weekly and sometimes almost daily check-ins at times to make sure that our agencies were all connected during times of high stress and when there was potential for missing a survey. We continue to make strides in new sampling techniques like eDNA and others that use visual recognition technologies paired with machine learning, and a whole slew of research that informs the management of key species in our ever-changing Delta ecosystem, everything from genetics to habitat. We've continued to pursue open data and focus on meaningful data stewardship that includes more than typical metadata and data management steps, because our hope is that this will not only improve data comparability and integration, but it should also decrease the improper use of data collected by IEP surveys. Our website includes multiple entry points for people to find our data, and this searchable data table also helps you determine which surveys are the most relevant to your project by showing which types of information they collect. There's also an interactive map and links to the data and the data repositories that use our data to provide additional access to it. A few years ago, we also committed to investing more resources into reporting and documentation, so we could really turn our data into more meaningful information. Some of this is presented through more complex synthesis efforts, as well as quick access information, like our summaries at a glance and the synthesis blog. If you haven't already signed up for notifications on the synthesis blog, you probably missed some pretty entertaining posts that are also really informative. Better communication of our data has reached beyond our website. There's a whole collection of IEP stories on the Frontiers for Young Minds website, where our scientists wrote stories for school-aged kids, and the kids reviewed them for refining before publication. These kind of endeavors really help us improve the way we communicate science with different groups. Meanwhile, we're still publishing in journals, compiling the IEP newsletters, and publishing our technical reports. And you can use the 125-page searchable library to find what you're looking for in the plethora of IEP documentation as well. One last thing I wanted to point out about our website is where you can sign up for job opportunity notifications. There's also links to the CalCareers and USA job websites at this site. I hope you all can appreciate that this website wasn't even in existence just a couple of years ago. It's been the hard work of the website committee and the commitment from everyone with information and data to provide content and update it as frequently as possible. So please keep those contributions and suggestions coming. Through it all, IEP is still the Nets on the Water collaborative that works together to serve the changing needs of our science community while staying true to the missions of our agencies. We push ourselves beyond what our own interest is to provide a broader benefit, growth, and efficiencies to our partners. Our linkages connect us like puzzle pieces to cover the landscape of what's needed. And we do this with people, as scientists who care about our natural resources and this world that we share with each other and future generations, because we are a community. Speaking of community, we recently got to show how our agencies can come together on a high-profile project with a very short timeline. With the dire state of Delta smelt continuing last year, it was clear that extreme measures were called for. So some of our partners quickly formed teams to see what we could do to release Delta smelt into a portion of their current habitat. It was a combination of research, not getting in our own way, and the mutual desire to help improve the status of an imperiled species. Everyone band together to sort through challenges and communicate and cooperate on a whole other level. The experimental release of Delta smelt was a huge team effort that really exemplified the spirit of IEP. People setting aside their timely priorities and rearranging schedules and devoting hours upon hours to the greater good. I hope you'll tune in to session 9 on Thursday morning to hear the details and fully appreciate the accomplishments made by the people of this community. So, what's on the horizon for IEP? I think we double down on the progress we've made and we build off of those reinvigorated relationships. Let's invest in the right resources to promote the reliability of our field operations, including the benefits of cross-survey knowledge transfer, where we can create space for our field staff to have backup support within and outside of each agency. Continue to explore new technologies that make our sampling, sample processing, or information gathering more efficient. We can take opportunities to dive into the world of artificial intelligence. We should deepen the complexity of our models while being very transparent about what is or isn't included in them. It's not enough to keep our surveys going just because it's the way we've always done it. Know why it's being done that way and help others know why by documenting it and documenting it each time it changes. We need to provide detail. And yes, this takes time, but there are payoffs. If people don't know why something is done a certain way or why the data looks a certain way, it's likely that they'll interpret it incorrectly. We should use multidisciplinary teams to really integrate our analyses, teach and learn from each other. Keep sharing your code. Help us all understand without fear of losing our own value, because the best teams are really made up of different kinds of experts who work together to broaden the overall value. And every MVP still needs a team. I wanted to leave you thinking about an article that recently came across my desk. There was a study in Australia where scientists were putting trackers on magpies. Despite previous testing of the tracking harnesses for durability, these magpies were not having it. They were able to remove these harnesses within minutes. These birds were helping one another without any apparent tangible benefits to themselves. They patiently used cooperation and problem solving to figure things out in a new way. And I encourage us all to adopt these behaviors. So the focus of this year's workshop is early career scientists, but it isn't a one-way street. Some of the things I value the most about my interactions with early career scientists are the new tools and the inspiration and creativity they bring. So I really look forward to session 2, where we'll hear from the Delta Science Fellows. If you need anything from your program support unit, you can always reach us at our general email address.
Good morning. Welcome to our workshop for 2022. I hope you find your time with us informative and useful. Reviewing a year of my colleagues' science in 15 minutes is not something I risk lightly, what with all the experience and talent in this audience. But recently, the IEP directors expressed interest in a short summary of our annual effort, so I decided to try and expand on these efforts for our larger group of workshop attendees. We have published several technical reports and a flurry of data sets to online repositories. The 5 highlighted here represent continuing effort to understand longer-term data records and management activities. First, the Flow Alteration Management Analysis and Synthesis Team, or FLOAT-MAST, has put together a long-term conversation and synthesis of broadly important contextual information on flow-related conditions in the estuary. This is necessary for understanding where other recent discoveries fit into our canon of understanding. This and other MAST reports are good background information for those who would like to know what our collective thinking is on an issue or ecological process of importance to species recovery and water project operations. Second, a pilot review effort of long-term monitoring surveys was made available in January 2021. This was an attempt to address long-standing shortcomings in IEP review responsibilities. The report recognized the need for reviewing and refocusing existing survey programs and cruises. The report recognized that reviews should continue to receive support and resources, should embrace the development of new analytical tools for understanding the appropriateness of existing modified or proposed sampling surveys, and should not continue to be evaluated using only traditional approaches. Clearly, we all have more to discuss in this regard as a cooperative community. Third, a report on enhanced control of aquatic weeds shows the usefulness of the Aquatic Vegetation Project Work Team approach to understanding the scope of the aquatic weed problem and the need for improved information. Also, for collecting all the correct people and expertise, for engaging the latest relevant science and remote sensing from wherever and whomever, for describing the issues and current state of affairs to policymakers clearly and directly, and describing the scope of implementation needed compared to the scope of current efforts at control and investigation. Lastly, I call your attention to the Zooplankton Integrated Dataset Metadata Report, and by now several follow-ons, including the shiny app Zoop Synth. This effort demonstrates the value of coordinating and collecting consistent data files for monitoring and subsequent interpretation. Removing obstacles from performing shared, transparent analyses and freely accessing existing and emerging data files is a hallmark of a relevant, robust, credible science enterprise. The talent we have seen come to the IEP over the last 10 years, well, okay, the last 50 years, but particularly over the last 5 to 7, in my view, has enabled the collective to substantially up its analytical game. Additional discussions and efforts like those described in the Zooplankton Project Work Team meetings and the report here highlighted are exciting testaments to the achievements of these teams and these scientists and the management entities that support them. Every year since I can remember IEP keeping track of such things, we've published dozens of articles in the referenced scientific literature, so much so that we've always struggled to keep track of the output, who is doing what, and what it all means. One way I've found to make an impression using the sheer numbers and subject matters included in this output has been to make a screenshot video of the bibliography I use to keep track of the IEP scientific publication output, and to just watch the article titles and author lists scroll by. This is this past year's set of about 40 IEP and IEP-related articles. It's an impressive list, and it represents a significant investment by 10 IEP agencies into the science of managing an estuary and keeping tabs on the fate of endangered species and other important natural resources, including water quality and water storage and management. So, what would you learn if you were to gather and read all of this vetted and accepted science reporting and all of this accumulation of information? Well, I don't know what you would learn, but I can, in a few minutes, attempt to pass along what I have learned and hopefully highlight for today's IEP workshop attendees what you may have overlooked in the broader IEP forum while you were busy at your other important day job. Perhaps importantly, from where I sit as the IEP lead scientist, I can provide some informed perspective of where this work fits into other related efforts I have witnessed and understood over the last 30 years as a scientist, citizen, and public servant in the San Francisco estuary. Now, I know I'll get some of this wrong or maybe just not quite right, but I think my perspective is like that many people may have and maybe haven't had a forum from which to share that perspective. I hope you can agree that these are perspectives we can continue our discussions from or use to increase our less than commonly held understanding. We're getting better at publishing management relevant science. Perhaps it is not yet, nor should it entirely be management driven, but our emphasis over the last few years has increasingly been on management useful or management informing science. So how best to organize the communication of this information? I think breaking things into triads is something most people find digestible and has some consistent aesthetic appeal. The first thing that occurs to me when I regard our last year's worth of output is that there are time and space scale categories into which your work can be easily sorted, as shown here on this slide. Also, rather than attempt to draw some sort of unique thread between all of these studies and provide some sort of pretentious insight into what all this research means or what it points to, I'd rather just call attention to a few examples from the list of articles you've seen me just scroll through that illustrates what the important issues are for the IEP, for IEP agencies, for IEP scientists, for IEP stakeholders, and reflect on what our last year's published record is telling us. Now, I know I've left out some sources, perhaps undervalued others, and maybe picked my personal favorites, but I am subjective, after all, as all human beings are. And while I try to be ecumenical in my approach and examples, I do have implicit biases, and I hereby acknowledge them. Your list will equally be as informative as mine and worth discussing. Please be reminded again to refer to the authors of these reports for the official versions of this research. So here are 4 examples from the literature for what I'm calling now as a focus. We've long searched for effective ways to sample littoral habitat, electrofishing boats, seining programs, and the like, even while the nature of the littoral habitat in the delta and estuary has changed over the last 50 years. It's challenging, but new technologies and boat designs will help us understand how littoral communities interact with an evolving estuary and influence existing fish communities, both native and non-native alike. Additionally, using local aquaculture or rice culture to produce food we can add to the estuary may alleviate problems associated with low food web productivity. Supporting landowners who already do this seems to me to be a worthwhile investment in a proven practice. Also, we know that fish respond to changing conditions and they make volitional choices. Our migration and survivorship models do well to acknowledge this. This is true for migrating salmon and for migrating smelt. Management of entrainment has suspected this for decades, and we can improve our estimates of impacts by acknowledging a simple truth that it's flow, but it's not just flow. If we broaden our focus a little bit to include the next few years, climate, specifically precipitation, will continue to be the principal driver of aquatic conditions in the estuary. Local water quality may respond to local manipulations, but must always be evaluated from a perspective that understands and includes larger scale and more persistent ecological drivers. Secondly, rerouting water from existing in-estuary uses can increase productivity and food resources to be added to the estuarine food web. This is an additional action we now have in our toolbox, and we should use it when it's available. Thirdly, an idea being articulated by Rosemary Hartman and others within the Zooplankton Project Work Team includes organizing our science inquiry around synthesis and study of San Francisco estuary zooplankton dynamics. Focusing on this organizational level in the food web and regional ecology holds promise for yielding insight into new relationships and new understanding of how ecosystem members interact. Lastly, drought lingers in ecological systems. Deleterious effects accumulate in the biota and degrade the resilience of ecosystems. Regional biological systems do break if stressed enough. For the last of these categories, what I've called on the horizon or with a Western regional focus, our underlying ecological system has been fundamentally altered, and to fix it requires understanding and management equivalent on magnitude and effect to the heretofore accumulated alterations. We need to chat more about this one, all of us. This is an important fact we need to confront in our estuary. Secondly, climate change will affect most things in the environment, and most things will be affected unequally. This will be a major challenge to understanding ecosystem function and management into the future. Third, restoration works, but there are caveats. But restoration works. Lastly, and not just for the San Francisco estuary, change is the norm, and it's happening sooner than we think or have been used to. This will challenge our social systems even more than they are now, and maybe even more fundamentally than our biological systems. So now that we've had a quick tour of what IEP scientists were publishing in 2021, where do I think we should head in 2022, 2023, and beyond? Well, I have 4 priority areas I feel are direct outgrowths of what we are learning now, and where I think we are likely to make management relevant progress soon. These observations are supported by the work from all of you, and that includes my rough estimate of about 180, maybe 200 working scientists who support, coordinate with, or are directly employed by the IEP member agencies. Number 1, remote sensing of ecological process. In other words, covering more ground and more water is an imperative here. Now, this stuff is expensive and requires the latest technologies and the latest trained scientists, but it will get us more of what we need to know more quickly than hiring small armies of additional field crews. Number 2, I think we should be focusing on using video illustrations for communication. We're in the Snapchat and Instagram culture, and scientists must embrace these modes of communication if they want their science stories to remain relevant and top of mind. Getting 3 to 5 minute videos of what we come to know from a given study might be the only way we have to communicate to policymakers. I'm sorry, but no one but other scientists reads your research papers. Thirdly, I think we should be purchasing the landscapes we want restored right now. We know what landscapes we need. We have an ecologist's notion of how they work. So locking up landscapes now into the possible futures we have envisioned for them is the most important investment we can make in this estuary. We need action and ownership, not just research. Lastly, data interoperability and free exchange of analyses. Now, happily, we're making great progress here, and every month IEP scientists publish in the open scientific literature and move more of our existing data archives to accessible internet repositories. We need to continue to make this data and its availability as useful and as interchangeable as possible by adopting standards of practice that drive our cooperation and compatibility as quickly as we are able. The era of lone wolf scientists with single copy data files on personal computers is over. Shared data is the only usable data. Now, I'd like to pull our focus out a little bit from the work itself and speak briefly about the sociology of how we conduct ourselves as scientists and managers in the estuary. In so doing, I'd like to highlight what I think is truly an amazing and useful construct of our science management community, the IEP project work teams, and this includes technical working groups as well. The way these teams have been organized, led by their own subject matter experts, guided by internally driven yet outwardly facing groupthink and sociology, incorporate what, to me at least, are the best characters of a homegrown and programmatically useful science enterprise. These project work teams, or centers of excellence as I like to call some of them, have been the source of much inspiration for me due to their creativity, their drive, their solution seeking, and the adaptability through time and through changing management imperatives. Groups like the estuarine ecology team, the flow alteration team, the biotelemetry team, the spring run Chinook salmon team, and the zooplankton team have all made significant contributions to our culture of shared science over the last year, and I think they should be celebrated as the paragon of community-based, management-relevant science. I believe the IEP Science Enterprise will be well served into the future by organizing its activities around these adaptable and durable working groups into our changing future for whatever environmental changes and challenges there will be. Additionally, I think we are approaching, or perhaps are already experiencing, a reckoning in our management-led science endeavors. Applied scientists have always striven to help solve problems, even when trying to operate within the ecological systems that may not recommend themselves to being solvable. Even a lighthearted characterization of how we try to analyze our data points, such as I've displayed here, points out the limits of our human-oriented conceptual constraints, and at least to me provides ample opportunity to discover just how ill-suited we, or at least our public institutions, can be at explaining what it is we choose to measure and figuring out what it actually means. What if, in our XKCD world, we just admit, occasionally, we don't know? And to this last point, and you've heard from me about this before at IEP workshops, let's remember why we are scientists or managers or policymakers. Those of us of this current generation that inhabit this miraculous blue marble. Since 1968, we have had this image available to help us understand where we are in the world and where the world is in the universe. This image has helped shape me more personally than most any other image I can think of, and I often wonder how, after seeing this image, and understanding visually at least the very sanctity of life on Earth, given all that we know and admitting all that we don't know, why still can't we do the better thing, the conservation thing, the restoration thing? In the end, I'm asking on all of our behalf, is all of this incredible, wonderful, estimable science we do just an ordinary distraction from what is really important? I'm hoping, and I will suggest, that we all go outside this evening, take a few moments to gaze at the stars, and ask ourselves simply that question. And with that, thank you for your attention. I hope you will enjoy the rest of the workshop. We have incredible talent among us, and I hope this will be a few hours or a couple of days where we can celebrate each other with all of our warts, all of our wrinkles, all of our human foibles, but all with a twinkle in our eyes and with unreasonable hope for the future on our fragile little bright blue marble floating through space. It is a pleasure to work with all of you.
Thanks, Steve. And as I mentioned in my earlier talk, we're going to hold questions and comments till the end of the session, but our next speaker is Denise Colombano.
Hi everyone, I'm Denise Colombano. Today I'm going to be talking about strength in numbers and how I think it can be used to advance estuarine ecology through data synthesis and collaboration. I'm a Delta Science postdoctoral fellow at UC Berkeley, where I work with Professors Stephanie Carlson and Albert Rui as part of a newly formed estuarine ecology team. We work on several Delta projects, ranging from food webs to fish community dynamics, and our main focus is trying to understand how climate change may impact the San Francisco Bay Delta. To give you some more background on me personally, I'm an avid field ecologist, someone who loves natural history and fish, especially in estuaries and tile marshes. I'm an enthusiastic data scientist. I love learning new ways to code and visualize data. And I'm also a basketball superfan, so I watch at least 82 Golden State Warriors games each season, and I say at least because we have been very fortunate to go to the playoffs in many of recent years. There are two pillars of my academic work. The first is ecological synthesis, leveraging multiple data sets in new ways to answer conservation and management questions. The second is team culture, participating in collaborative research teams that are hardworking and dedicated, but also unselfish and fun. In terms of ecological synthesis, I focus mainly on these elements. How does habitat complexity, environmental fluctuations, and habitat connectivity influence ecological responses in the estuary, and particularly for fish communities and food web dynamics? So the purpose of the ecological synthesis that I do is to generate knowledge and insight into the ecology of our highly dynamic and ever-changing system. In terms of team culture, I've come to the realization over the last 10 years that my ideal research team has a culture of hard work and dedication, as I mentioned, but also respect, trust, unselfishness, creativity, and joy. So basically what I'm saying is that my ideal research team is the Golden State Warriors. And let me show you what I mean. I want you to watch this team's chemistry and how much they share the ball.
Third longest streak in NBA history with a three made. Raymond on the kick out. Better pass. The flyby, return it. Wide open, good!
NBA's MVP last season. He averaged just under 24 a game. Golden State Warriors last season, 39-2 here at home. Oh,
Since I'm just one of many scientists who adore the Golden State Warriors, I decided to interview others to get their insight on team culture. What does the team motto mean to you?
It means that everybody has a responsibility for like the shared success of the team.
There's more than each person's individual contribution to the team. It's all about the team first mentality.
I think it's definitely recognizing everybody's strengths as well as their weaknesses to be able to play up what one needs at the time.
It's very much a team attitude, right? It's not like strength in our star player. It's strength in everybody knowing their role and, like falling into that team dynamic.
That everyone's able to contribute and that the team is giving back to everyone equally.
How does this apply to research teams?
Being able to essentially decenter ourselves and work on projects together in unison, but always being able to help and collaborate with others allows us to do more. It allows us to kind of stretch the boundaries of our own disciplinary silos and be able to work on projects that maybe is not our first expertise or would be our first choice, but allows us to really stretch that muscle of a brain so that way we can better understand how the entire system is connected.
Many of you in the IEP community may remember that I started out working on the Delta Largemouth Bass Project. led by Drs. Andy C. and Louise Conrad at UC Davis. And this was my first experience with a collaborative research team that had strong leadership and a culture of hard work and dedication, but also that unselfishness and that joy. So as a technician, I learned technician things. I learned to drive a boat, sample vegetation, and identify delta fishes. Here are some of the most common species in the interior delta fish community, a majority of which are non-native. We found that largemouth bass are associated with warm water and submerged aquatic vegetation, signaling a self-sustaining littoral community dominated by slow-moving warm water and invasive species. And our team published numerous peer-reviewed publications, a curated database with a full metadata report, and me, a technician, I was invited to think critically about what I was observing, ask challenging questions, struggle to learn new things like data analysis, and even help write these peer-reviewed papers. And as a result, I became a published author, which not only helped my CV, but also gave me insight on the entirety of the publication process. Being one of many contributors to the Delta Largemouth Bass Project, with all of our team members and all of our skill sets and all of our data sets, was a very formative experience for me and prompted me to pursue graduate school. In addition to this amazing experience with a healthy team culture and wonderful mentoring, my interest research peaked when in 2011 we started sampling fishes of the North Delta, where instead of largemouth bass and red ear sunfish in every single survey, we were capturing these absolutely beautiful native fishes: white sturgeon, delta smelt, Chinook salmon, hitch, splittail, and blackfish. Not only was I in fish biologist heaven, but this project sparked my academic curiosity in the question: what makes certain areas or habitats in the Delta good native fish habitat? With lots of guidance and coaching from my mentors and my peers, I enrolled in graduate school at UC Davis, where I joined Dr. Peter Moyle's lab in the Sassoon Marsh Fish Study, truly the honor of a lifetime. This is a long-term monitoring study that's been carried out by dozens of graduate students, hundreds of undergraduates and volunteers. It's a heroic team effort, and I expect that many of you in the crowd have also been on these boats, pulled these nets, admired these native fishes such as tule perch, starry flounder, and Sacramento sucker, and learned a ton about the ecology of the estuary, just as I have. Now, that being said, I really struggled at times during graduate school. I was in charge of my own research projects for the first time. I was spending 50 to 60 days a year sampling the marsh while taking classes and TAing, and I was helping with other field projects too. But that all changed once I received the Delta Science Fellowship. It gave me the freedom to think deeply about my questions and to learn new skills like coding and modeling that helped me answer my questions. So I want to express my gratitude for the opportunity to participate in the Delta Science Fellows Program, which has truly been a game changer for my career training and development. For my dissertation work, one of the things that really interested me most about Sassoon Marsh is that not only does it look very different from the interior delta, but it's long been considered an important fish nursery in the estuary, for the entire estuary, for numerous species, for native and non-native species. So I decided to look more into the roles of specific habitat types as nurseries. In the nursery role hypothesis, the idea is that tidal marshes often function as nursery habitats by providing vegetated cover and food resources, which together enhance growth and survival of juvenile fishes and ultimately facilitate migration or recruitment to adult populations. Now, Sassoon Marsh has experienced extensive landscape change due to diking and draining of tidal marshes. For instance, this is a beautiful aerial photo of Rush Ranch taken by Dr. Carson Jeffries from a helicopter in 2017, which was a year of record high flows. So notice that there's a reticulate tidal marsh channel network, a gradual upland transition zone, and this is surrounded by managed ponds that at the time were overtopping. There are large slough corridors connecting the whole marsh to the open water Sassoon Bay. And despite the fact that it's been highly altered, it's still largely managed to produce food in ponds that are managed for waterfowl. This is in stark contrast to much of the Delta, which has not only been extensively diked and drained, but a majority of its marsh and floodplain habitats have been replaced by agricultural fields. And as a result, there's much less net primary productivity from the system, as shown by Klern et al. In their recent paper. I teamed up with Dr. Amber Manfrey, a postdoc in the Moyle Lab at the time. I'm sure many of you know her and her beautiful maps. Together, we quantified the area of a given habitat type, whether it was managed pond, tidal marsh, upland, or a combination of these three that we just called land, within 200-meter boundaries of the channel margins. And we divided those areas by the area of open water to quantify land to water ratios. To orient you, this is a two-dimensional ordination. It's a dissimilarity matrix of samples, where the gray points represent study sites, the arrows represent significant fitted environmental variables, and the ellipses represent two categories: sites with a higher land to open water ratio versus sites with a lower land to open water ratio. And in ordination space, things that are closer together are more similar. What we found for each species that we examined is that while they may have started out in one habitat as juveniles, they typically shifted to other habitats as they grew to adulthood. For example, striped bass moved from shallow, warm, vegetated habitats as young of the year to cooler ponds as adults. Splittail had a similar pattern as striped bass. In contrast, tule perch have smaller home ranges than striped bass and splittail, and they shifted from marsh habitats to marsh habitats next to ponds. Starry flounder, on the other hand, were strongly associated with deep open water dominated sloughs, which was quite different than the other species. The key takeaways of this study were that yes, individual habitat types functioned as nurseries for fishes, but overall, the habitat mosaic is what supports multiple life stages of fishes with diverse life history strategies. Put another way, a habitat mosaic has diverse opportunities for fish to move around and to find favorable conditions for foraging and growth. And this is a synthesis effort that was only made possible due to our strength in numbers. Numbers from an amazing long-term monitoring data set, but also a diverse skill set among the researchers on the team. After looking into the nursery role hypothesis, my next goal was to look at the trophic relay hypothesis to better understand the role of tidal marshes in providing food to fishes in the estuary. So here's a conceptual model of a trophic relay, by which intertidal marsh production is transferred to the open estuary through a series of predator-prey interactions. And so the idea here is that primary consumers feed on primary producers in the marsh, then secondary consumers feed on primary consumers, and ultimately this relays marsh production to higher trophic levels, which then move out into deeper habitats. It's based on the idea that there are shifting interaction zones between predator-prey as a function of habitat and tide. So here's a tidal marsh during an incoming high tide, where the red lines indicate hypothetical hotspots of predation on marsh nekton. And this would be up against the marsh surface edges, where small fish attempt to seek refuge in deep water. Here's the same tidal marsh during an outgoing low tide, where the red lines once again indicate hypothetical hotspots of predation. But now they're in the intertidal-subtidal confluences, the subtidal open water confluences, and the subtidal open water areas. We tested this hypothesis with three main approaches. Our first was to use Thomas Hanley, a master's student at the time, his amazing bathymetry data set, showing this transition from low elevation marsh and subtidal channel beds to high elevation marsh with intertidal channel beds. We also used gill nets that were randomly stratified by habitat type along this gradient and by tide, whether the tide was incoming or outgoing. Here are photos of some of our awesome team members, including Emma Davidson, an intern at the time who now works on the CDFW tidal wetland monitoring team, and was clearly excited about the striped bass that we caught in an intertidal channel during an early morning high tide in the middle of summer. We looked at the diets according to each species feeding guild. So for example, planktivores, benthivores, or piscivores. We use spatially explicit generalized additive mix models and a soap film smoother to look at fish abundance. So here, small-sized planktivores were overall more abundant at lower tides, but particularly during incoming tides. They were less abundant at higher tides when there was deeper water. In contrast, piscivores had the opposite pattern. They were less abundant at lower tides in shallow water and more abundant in high tides, but particularly in deeper pockets of water in the subtidal open water habitats and confluences. So this started to make some sense in light of the shifting interaction zone hypothesis. Small fish can seek refuge in shallow water to avoid predators. Surprisingly, we found that very few fish had empty guts, and in fact, there were high gut fullness scores across species and guilds. Planktivore diets were dominated by mysids, larval fish, detritus, and some amphipods. Benthivore diets were dominated by amphipods, isopods, nematodes, clams, and detritus. Piscivore diets were all over the place. Larger striped bass ate anything and everything, including small fish, crayfish, shrimp, crabs, mysids, amphipods, and even chironomids. And Sacramento pike minnow, which has been shown to have very similar diets to striped bass in the Sacramento River, only had detritus in their guts, which we think might be an artifact of their propensity to evacuate their guts when they're captured in gill nets. Our top-ranked gut fullness model also yielded some really interesting results. Regardless of species, during incoming tides, gut fullness was highest in subtidal reaches. During outgoing tides, the pattern was slightly opposite, where gut fullness was high across the entire elevation gradient and including in these shallow intertidal reaches. Together, we inferred that small fish actively move into marshes to feed when they become inundated, and then predators move into the subtidal areas when they become sufficiently deep to ambush their prey. Overall, after the marsh has been flooded and the tide is going back out, fish bellies are full across the board, regardless of species or feeding guild. Based on our findings, we developed a simplified conceptual model where we hypothesized that tidal marsh hydrogeomorphology can drive tidal exchange with emergent vegetation, which supports benthic invertebrates and benthivorous fishes, representing a benthic food web pathway. Alternatively, it can drive mixed resonance time and phytoplankton production in the open water column, which supports zooplankton and planktivorous fishes, representing the pelagic food web pathway. Now, overall, we assert that tidal marshes can support diverse food webs and foraging by multiple feeding guilds, including piscivorous fishes that ultimately can relay this production to open waters. Once again, this was an amazing strength in numbers exercise. But our strength in numbers is not just from our study alone. There is accumulating evidence from all sorts of other studies showing the ecological importance of tidal marshes to food webs and fishes. This is ranging from Sassoon Bay to South Bay and the North Delta. And here's a list of recently published papers that I encourage you to check out. So while this is amazing news, we are unfortunately already committed to a certain level of global warming. Whether it's 1.5 or 2 degrees Celsius, we are already committed to a certain level of sea level rise. And this means that our current and future restored marshes are vulnerable to going underwater. And Sassoon Marsh, the areas that are going to be the most resilient are those that are adjacent to uplands, whereas the managed ponds will be the least resilient due to subsidence and overtopping of levees. And I just want to give a quick shout out to the amazing people out there that are working on climate change adaptation strategies, like SFEI and the Delta Stewardship Council. I highly recommend checking out these online resources. Unfortunately, this isn't just a regional issue. This is a global issue. So for this paper, I collaborated with a team of saltmarsh ecologists from around the world to synthesize information on climate change and tidal marsh food webs. And we found that among many stressors, sea level rise alone is going to cause channel expansion and conversion to open water, runaway pond expansion, issues with marshes that are trying to migrate but being constrained by existing infrastructure, but also opportunities to let marshes migrate into upland transition zones, which is viewed as the most promising strategy for marsh resilience under climate change. This work was one of many products resulting from a surf workshop in Alabama, which was another highly successful collaborative research team that I'm very fortunate to have been a part of. We revisited this textbook, Concepts and Controversies in Tidal Marsh Ecology, which was published in 2000. It was a very neat experience for me because I was able to meet many of the original authors, Mike Weinstein, Jean Turner, Carolyn Curran, Linda Deegan, Ken Abel, Lawrence Rosas, Tom Manello, Juice Sebrian, Rod Connolly, and more. And the main conclusion of this workshop, after days of presentations and discussions, is that we don't have the luxury to sit around and argue about small details in textbooks anymore. We need to act now to prevent widespread loss of marshes, their food webs, and their support of fisheries. And the workshop coordinators made it clear to us that those of us in the younger generations, we are being handed the torch now. It's critical that we get involved and become leaders and thinkers and problem solvers to work toward marsh preservation. So this experience motivated me to write another Delta Science Fellowship proposal, this time on climate change impacts on the Delta, and also to join the IEP Climate Change Project Work Team, which I encourage everyone to check out if you haven't already. So as I said at the beginning of this talk, for the last 2 years, I've been working as a Delta Science postdoctoral fellow at UC Berkeley, looking at climate change impacts on fishes, which I will be presenting on in the next session. So this is an absolutely wonderful team with great, thoughtful leadership. And I have now stepped into a new role of mentoring, which I view more as an assistant coach position and something that I'm extremely excited for. We just started working on a CDFW Prop 1 funded project on climate-driven food web mismatches. We hypothesized that climate change may shift phenological responses among food web components, such as phytoplankton, zooplankton, or forage fishes. And based on the direction and magnitude of change in timing and overlap among these components, there could either be a trophic match, leading to high juvenile recruitment of forage fishes, or there could be a trophic mismatch, leading to low juvenile recruitment of forage fishes. Not only is this project another strength in numbers team effort, but we are hoping to leverage the strength in our data sets by using an open science framework. So our goal for this project is that every step is documented in a seamless, reproducible workflow, starting from the beginning and going all the way to the publication of the report. We also hope that this workflow uses open source software, open data, and publishes the report open access for full transparency, sharing, archival, and discoverability. But this is not just a collaborative synthesis team at UC Berkeley. This is an effort that's advised by Jim Hobbs, Noah Knowles, Lisa Lucas, and Jim Klern that leverages numerous publicly available data sets and builds on much of the amazing work that has already been done in the IEP community. Now, back to more analogies. The Golden State Warriors team culture one that is collaborative and based on trust and unselfishness, can be applied to individual research teams, of course. But it can also be applied to our IEP community at large. We all play different roles and we all have different strengths and weaknesses. Some of us contribute to model development and application, new tools and approaches, advancing DEI, extension and public engagement, data curation and creation, knowledge generation, synthesis, and linking disciplines. Collectively, our contributions are rivers that flow into the same estuary of products and outcomes, one that advances our ability to manage a healthy ecosystem despite its many challenges. So with that, I want to thank everyone in the crowd, whether you are pulling nets on a boat, entering data, publishing data, writing reports, granting permits, balancing budgets. Whatever it is, thank you for your contribution. I appreciate you. And as a long-term data synthesizer now myself, I couldn't do my job without you. Now I'm going to leave you with a number of different ideas to reflect on, whether you're a mentor or a mentee, on how to cultivate a successful, healthy team culture.
My advice would be to kind of personalize the mentoring style and custom fit the mentoring style to fit each mentee. I would also encourage them to create a culture, kind of a larger culture for everybody to buy into. It creates a standard and it helps everybody hold each other accountable. And if you can get everybody to buy into that culture, then it kind of almost becomes like its own self-sustaining system. And within that system, you celebrate you celebrate heavily each other's victories, even small ones, and you lift each other up when people kind of mess up and things like that.
If you're studying the ocean, you could think sort of like competitively that you're trying to, I don't know if win is the right way to think about it, but you're definitely trying to like accomplish getting this knowledge. And thinking about that in the team way versus, trying to compete with other individuals, especially if they're on your own team, I think is a healthy way to look at it.
Getting everyone involved with each other's work in as many ways as possible is going to create a space where you're all excited to work with each other, that you see your efforts as being like communal, as well as being extremely individually beneficial, because suddenly writing that paper or finishing that field work or getting that experiment done is no longer so onerous on you by itself. It's a team lift.
Your advisor is not going to be that one coach who knows everything. That's why you have your committee. And that's like analogous, I guess, to that coaching staff. Your committee is that coaching staff.
Oh, good.
You have everybody on your committee. Like on my committee, I have somebody for ecology, someone for like cell biology, somebody for physiology. That's my coaching staff. And then head coach is my advisor.
You need to have plasticity in order to understand how you can interact with and help out students that frankly are going to be different from each other, right? So the students that I have that are in the lab right now, I use certain strategies for some of them and certain strategies for others. I don't use the same strategy for everybody because not everybody is coming in with the same knowledge about their system, with the same interests. They're different people just generally based off of where they grew up, what their family structure was like. So for me, it's all about learning from their perspectives and then thinking about how can we co-produce the ways in which we scaffold your learning, knowing full well that for me, I'm taking myself out of it and really just being a listening board.
With that, I'd like to say thank you to all my funders, thank you to all my collaborators, thank you to the Carlson and Ruhi Lab and the Moyle Lab and the C Lab for everything that you've taught me. And please stay tuned for Lauren Damon, who's going to come up next with a wonderful plenary.
Thanks, Denise. And as we said before, we're going to hold the questions until the end of this plenary session. And so with that, Lauren Damon's next.
For most of the last 14 years, I worked for the California Department of Fish and Wildlife in the Stockton office, conducting many of the long-term and real-time monitoring surveys that fall under the IEP umbrella. In Stockton, we refer to our program as IEP operations. In IEP operations, we turn early mornings, long days, sweat, fuel, sore muscles, wildfire smoke, and a million tiny tide knots into many gigabytes of estuarine data. Each year, we spend over 400 boat days on the water, collecting over 5,000 fish and invertebrate samples. We do all of this work with 7 boat operators, 5 fish and wildlife technicians, 11 environmental scientists, 11 senior laboratory assistants, and 4 senior environmental scientists, and 5 to 15 scientific aides. It takes all of this staff to collect, sort, and enumerate the 200,000 fish and 25 million invertebrates we catch each year. That's the role that many of you know me from, but for the rest of today's talk, I want to talk about another version of IEP OPS. This version includes opportunity, purpose, and the shoulders of giants that we are all standing on. I believe that it's these 3 points that make IEP an amazing community to work in. The last 2 years have left all of us very isolated and without our normal community of people. If you are new to IEP, you may not have been able to fully enjoy our community just yet. But as we enter a new season of hybrid approaches to meetings and interactions with colleagues, my hope is that we can get fully immersed again into our community. I'm going to share the parts of IEP that I think were foundational to my early career, and also foundational to making IEP not just a program, but a great place to work. I believe that it's the sense of community and collaboration in IEP that continues to make it effective and relevant. I ended up in IEP based mostly on luck. I started my career with CDFW in 2008 as a seasonal employee, but we're going to go back a little farther than that to a couple of pivotal moments that shaped the path to the career I'm in now. As a kid, I always loved the outdoors, particularly places with water like lakes and the ocean. And I was a total biology nerd in high school, but I didn't come from a family of environmentalists. I came from a family that was blue collar and valued hard work, and we ate off paper plates. The only reason we ever went outdoors was to go look at hot rods and to drive our boats and our four-wheelers really fast. My family wasn't college educated, and my holidays got weird anytime evolution got brought up. The only career path in science that my family was aware of was the medical field. And in my family of origin, having an environmental job just wasn't an option because we weren't aware of it. I was admitted to major universities just after high school, including MIT. But when my family looked at the finances and the cost, they just could not see the value in it, especially when the junior college down the road was almost free. Turns out the decision to go to a junior college worked out extremely well for me, as the classes were small and we took immersive biology trips all over the Sierras. I was also introduced to a local community of barefoot hiking, tree-hugging hippies, and through one of my dear friends, April. She somehow convinced me, without any real evidence, that jobs working outside did in fact exist. So after 3 years at the Modesto Junior College, April and I transferred together to UC Santa Cruz for ecology and evolution degrees. The spring between junior college and moving to Santa Cruz, my mom told me that she had found a summer job for me. If I found a summer job, she means she found this classified ad that looks exactly like this slide. That was it. That's the only information I had to go off of. But being unemployed and the adventure seeker that I am, I decided to give whatever it was a shot for the summer. That's how I ended up at the UC Davis Fish Culture and Conservation Laboratory in Byron. I spent the summer of 2007 feeding Delta smelt and cleaning their tanks. Although I had spent much of my teenage years boating and water skiing on the Delta, the FCCL is where I learned that the Delta was in peril and that these pretty silvery blue fish that I took care of every day were actually going extinct. I had many questions about why Delta smelt mattered, and mattered enough to build a hatchery for them. The director at the time, Joan Lindbergh, leaked to me that plans for a refuge population were in the works in the case that one day Delta smelt may need to be released. I took this opportunity with her to ask a bunch of questions, but I also noticed that there was boats and equipment being stored in the building that's now the refuge facility, and staff taking the boats in and out to Clifton Court Forebay. It was at this moment that a career in fisheries became an actual option for me. It was a career path that I didn't know had existed until then. And one opportunity in a classified ad in the newspaper was already leading to several more opportunities. The next summer, I was applying to seasonal jobs in the Stockton office, the CDFW Stockton office. And although I got turned down a few times, I finally landed a job there in August. This first job was taking photos of larval fish for a reference collection. During that fall was my last semester at school. I worked 2 days a week in Stockton and 3 days a week I drove to Santa Cruz. The thought of doing all that driving now exhausts me, but I was so hungry to absorb all the information that I was learning, and I loved every part of it. In my freshwater ecology class, I wrote my final report on the pelagic organism decline. Although I wanted it, a career of scuba diving in Fiji or camping in African forests like Jane Goodall just didn't seem very feasible. However, a career catching fish was realistic, and I would have never known that if I wasn't willing to take a few chances and work really hard. For various persons, one of them including an infant, and the other including not wanting to start my life as a new mom in major student loan debt, I didn't attend graduate school as planned during the late 2000s recession. Many agencies were having hiring freezes, so there was really no chance of permanent work. But I signed up for my third year as a seasonal, and in our off season also took short jobs with U.S. Fish and Wildlife Service, Delta Juvenile Fish Monitoring Program. Lucky for me, after a couple hard years as a seasonal, the hiring freeze ended in the fall of 2011, and I was very eager to move up. I prepared for my interviews for weeks, and I got offered 2 jobs at CDFW. I truly believe that hard work and dedication were my saving grace during those hiring events. I had committed to the work, I gave it my all, and it definitely paid off. During my 6 years as an environmental scientist, I took every opportunity I could reasonably justify taking. Mostly, this included a bunch of leadership and communication classes, but I also took an opportunity to co-chair a strategic planning team. The strategic planning committee literally changed the way I view and I plan my life, personal and professional. Every decision I make gets filtered through a strategic planning lens, and it has made me happier, more productive, and more focused than any other decision I've made before. We're going to come back to this later, but this is a basic strategic planning framework where time is on the x-axis and success is on the y-axis. However you measure success is up to you. That's a personal choice of whatever metric you want to measure it in. Where you are right now is the y-intercept, because that's time 0. At the far end of our graph is the future state you want to be in. This is when you've reached the success in whatever metric you have chosen and what your later looks like to you. The way to get from now to the future state is by taking the green path. This path encompasses all of your experiences and all the opportunities you take along the way. Early in life, when the future state is very fuzzy or completely undefined, your experiences and opportunities will lead you, and your green path will definitely not look this straight. But as your future state gets clear, the path and opportunities you take will become more intentional and more along this straight path. Here at IEP, the opportunities abound. Depending on your values and your interests, you get a choice of 9 different agencies and also numerous partner agencies to work for. Pro tip for every early career scientist: do not burn any bridges with any people that you work for. Everyone at IEP knows each other and we talk. In addition to your choice of agency, you can also choose from any of the subjects on this slide to settle into. There's a whole bunch of things here, and I'm sure there's many more. This is just what I came up with. The great thing about being in an interdisciplinary field is that even if you get into something and then change your mind and you want to get into something else, it is never a waste of time. Look at all your options and look at how they connect. Given my participation on the spring Kodiak trawl and the 20mm survey, my scientific interests are in delta smelt reproduction and productivity. Since this occurs in the spring after their winter movement upstream, this is also the time period that fish are most vulnerable to entrainment. The opportunity that's presented for me was to learn about entrainment management and water operations regulations. The studies I was leading directly informed water operations management, and that's a whole complicated world, mostly outside of IEP, that I wanted to learn more about. So I decided to follow that opportunity. I took a promotion with CDFW in our headquarters in Water Branch. Our Water Branch handles many of the regulatory functions for the Delta and its tributaries as they pertain to statewide water operations. Taking this opportunity gave me insight into how regulatory parts of CDFW work. But it also made me aware of how truly unique IEP is. In IEP meetings, we're able to take off our agency hats and focus on the science. Our goal, as Randy Brown stated, is to get the science nailed down. We let the science lead us to the answers and don't let the answers lead the science, which leads me to the P in OPS, purpose. I read a book a few years ago by one of my favorite authors and speakers, Simon Sinek. One of his books is called Start With Why, and it clarified to me why IEP felt so much like a community. Sinek's theory is that people are not inspired by what an organization does. They are inspired by why an organization does it. He argues that the purpose of an organization is not in what they do, but why they do it. Sinek demonstrates that clearly defining an organization's purpose, or why they do what they do, speaks directly to the emotional part of the human brain. This purpose can build trust, inspire action, and emotionally connect us to others in a way that facilitates communication and collaboration. At IEP, we are very lucky to have a clear purpose, and that's in the form of our shared vision statement. The IEP vision is: the highest quality science contributes to achieving a reliable and sustainable water supply and a healthy Bay Delta ecosystem. This shared vision solidifies the reasons we all show up to work every day, why we work collaboratively with our peers, and why we're willing to write the 200-page reports. The shared purpose is our reason to show up to work every day and do the things that we know we need to do. In strategic planning, a mission statement is where you are currently. Remember, that was time 0. And the vision is the future state you want to achieve. We called that later. The mission describes what you do, but the vision is why you do it. Sharing a common vision or a common why, as Sinek discusses, with other members of your organization fosters connection and collaboration. This is why we can work so effectively with other agencies at IEP events, because the agency hats are off and we're working together towards a shared vision. As a thought-provoking exercise for myself, I Googled all the missions and visions for each of the 9 IEP member agencies. I could not find visions for all the agencies, but when comparing missions, I found that some were very similar to others, and some that I thought were very different than I had expected. So today I want to play a little game. I'm going to display a mission statement and a list of the 9 IEP agencies, and at home, you can see if you can match the correct answer. For this exercise, you're invited to use the Q&A box in Zoom to post your guess. I can see them there. but don't give away your answer of the agency that you work for. So the first mission is to preserve, enhance, and restore the quality of California's water resources and drinking water for the protection of the environment, public health, and all beneficial uses, and to ensure proper water resource allocation and efficient use for the benefit of present and future generations. Go ahead and put your guesses in the Q&A box. I see one already for DWR. There's a couple for DWR, couple for State Water Resources Control Board. This one to me was a hard one too. This one is actually the State Water Resources Control Board. Next mission, to sustainably manage the water resources of California in cooperation with other agencies to benefit the state's people and protect, restore, and enhance the natural and human environments. What do you guys think? Okay, I see DWR, DWR, DWR. Now this one is DWR. Yes, this one is in fact DWR. Interesting how close they are, right? The last one we're going to do today is to manage, the mission is to manage California's diverse fish, wildlife, and plant resources, and the habitats upon which they depend for their ecological values and for their use and enjoyment by the public. Okay, already, you guys, this is an easy one for a lot of you, it looks like, because everyone same answer, and everyone that put in is right. It's the California Department of Fish and Wildlife. Awesome, thanks so much for participating. These are pretty interesting, right? To visualize the similarities among the missions, I put all 9 of the IEP agency's missions into this word cloud. Words like environment, enhance, water, wildlife, public, resources, human, natural, quality, and people appear in multiple of the agency mission statements. While the IEP vision statement has slightly different language than what you see here, based on the individual mission statements, the sentiment of it feels the same to me. I'm going to read the IEP's vision statement again while you guys look at this word cloud. The vision is the highest quality science contributes to achieving a reliable and sustainable water supply and a healthy Bay Delta ecosystem. While the origin of the phrase standing on the shoulders of giants dates back to early Greek philosophers, this phrase was most famously written in 1675 by Sir Isaac Newton to a fellow scientist. If I have seen further, it is by standing on the shoulders of giants. He might have been taunting his colleague, but what he meant was that each scientist can progress science a little farther than the scientist before him, because he knows what the scientists before him learned. IEP founders realized 60 years ago that we could manage the ecosystem and water operations better together. We could stand on each other's shoulders. I think 60 years is a lot of shoulders. The origins and history of IEP is fascinating, and it's been documented in Perry Hergesel's 2012 report, which is available on the IEP webpage. To be honest, I wanted to spend my full 30 minutes reading it out loud to everyone, but I thought that that probably wasn't a very good idea. However, this is a brief timeline of when the 9 agencies joined into the MOU. My favorite line of the most recent version of the IEP MOU, which was signed by all 9 agencies in 2016, reads, "The parties intend to work collaboratively and anticipate a need to share party resources to effectively implement IEP work plan elements." The word share is in this 4-page MOU 4 different times. Establishing these formal agreements means that when the agencies disagree, we have a forum to work it out. We have a forum to work on the science together. We share 60 years of historical data, 60 years of great minds, 60 years of resources, data, studies, monitoring, testing, trying things out, thinking, creating, and reporting. These are huge shoulders for us to stand on. This is what standing on the shoulders of giants looks like. Being deep in creativity or discussion at your favorite project work team, or participating in this annual workshop. Management needs change rapidly and frequently, but for 60 years, IEP has shown up and collected the data. In my relatively short career here, I've watched many of these relevant questions turn into answers. The mundane day-to-day is also what standing on shoulders looks like. Sorting through debris to pick out fish, or participating on justice, equality, diversity, and inclusion meetings to ensure participation by all into the future. Standing on shoulders is taking what others have found and using it as our springboard to propose the next idea, to fill in the next missing piece that management needs to make decisions. Here on the screen are just a few of the hundreds of examples that we know of what we know based on decades of data. It's hard to imagine IEP without long-term monitoring for fish, food, water quality, and hydrodynamics that indicate the changes we've seen over many decades. Without continuing to collect this data, how would we monitor climate change? How would we know how ocean currents or outflow affects distribution and an abundance of array of organisms? Most importantly, how will we know when species have recovered? My final words to you all are a reminder to take all of the opportunities that you can find out your shared purpose and share it with others, and stand on all the really tall shoulders that you have around you. Thank you so much for your attention today, and please enjoy the workshop.
Thanks, Lauren. So with that, I encourage folks to go ahead and submit questions through the Q&A box, or you can raise your hand and I'll try to make sure that I call on everyone in order. We did have one question earlier for Steve, and that was from Steve Brandt, and he was wondering if you could make your bibliography available.
Yeah, thanks for asking, Steve. I certainly can do that. One of the things we're working on behind the scenes is to populate the IEP library, the bibliography that's there. We still haven't figured out a functional way to make sort of a quarterly update available, but we're working on it. And in the meantime, send me a quick email and I'll give you a Word version of what I have.
Okay. Maybe while people are sending in their questions, I actually had a question for Denise, because when you were going over the gut content between striped bass and pike minnow, how they were so different, and it sounded like you were implying that that was probably a behavioral difference because of the way they react to the nets. I just was wondering if there was any next step at looking at like cortisol levels or things like that for different fishes when they're in these types of environments, so that they may inform our future sampling.
So there's nothing planned right now, but Dylan Stomp wrote a really great paper from his master's thesis comparing the diets of striped bass and pike minnow from the Sacramento River. So I encourage everyone to look at that. They have better sample sizes. We only captured for adult pike minnow in that particular gillnet study. And yeah, we were definitely surprised that they only had detritus, but Peter had said that when they sampled pike minnow in the Eel River, they commonly saw, like, which is clear water, they would see the pike minnow, just like, as you said, like react to the gillnet by evacuating their gut. And so we weren't able to characterize their diets that way, but we just said in the paper, maybe there is higher, predation risk from these pike minnow that we're not capturing. But I do think that if someone was interested in studying pike minnow, that would be really valuable, since they're the original piscivore in the system, and oftentimes they're overlooked. And so I really think that any more information that we can get about pike minnow and their role as top predators is really valuable.
That's great. Thanks. So still not seeing any questions, but we have roughly 10 minutes. I was hoping maybe, Lauren, you could speak a little bit to the fact that, I think we have a shared experience where we had some opportunities that maybe we weren't able to take at that moment because of other circumstances. And it seems like you've really chosen to take this on with a positive attitude rather than sort of, bummer, woe is me, I really wish I could have done this thing. Is there anything else that you'd like to maybe share with the early career scientists about how to get yourself beyond that initial feeling of woe is me?
I definitely did feel that way initially. It felt like I was going to be wasting a lot of time and I was going to get behind. But if I could tell, if myself now could tell myself then, don't worry about it. It's going to work itself out. Opportunities will come. They always do. There's always opportunities, and I think that's, you just dealt what you have, and you take the opportunities that show up. And you can also find different ones. So even if it wasn't exactly on your green path, like in strategic planning, you have a later that you want to get to. And if it wasn't on that green path, that line, something else will be, or you can take a little detour, and you never really know what will help you later. So I was able, because I didn't go to graduate school, I was able to be at an agency and take classes that were available to me. And so I could take leadership courses, and I could take strategic planning courses, and I could learn other skills that made me valuable that weren't necessarily along the path that everyone else I felt like was on. So to those of you who feel like you have to be on a certain path to get to a place, you don't. There's many paths that go to many different places, and where you're going to end up is the path that you need to be on, not the path that everyone else is on.
Okay, so it looks like some of the questions are coming in now. And we have a question, well, a comment first, and then a question from Michelle Youngbluth. And she says, as an early career researcher at a university, I think one of the challenges I have with wanting to collaborate more broadly, but not feeling like I can as much as I want to, is that I often cannot offer to pay the person to collaborate with me. So I feel like I would be asking for people to work for free. Of course, putting this into a grant up front would be helpful, but grant funding is limited, and we cannot always include support for a bunch of salaries beyond our core researchers. Do any of the panelists have any recommendations on this topic? Any thoughts, folks?
I think that's a really valid point, that collaboration outside of our universities or our agencies requires labor from others. That is time and effort. And so we don't want to ask people to do unpaid labor. For me personally, the way I get around that is I spend a certain amount of time on my regular projects, and then I squirrel away some time for fun side projects. Don't tell my bosses I just said that. But anyways, that's kind of how I get around it. So I don't know, maybe someone else can provide some insight.
I actually think that what you provided is a lot of what most of us do, because for any one known, stick in the fire, we probably have 10 or 15 little things that are somehow connected to that main thing, that are our true interest that is not yet taken hold with someone else. So I always think of these things as things where this is where we bring the ingenuity and the creativity, right, as real scientists, because your pet project is really the thing of tomorrow. most often. So I applaud everyone for keeping all of those sticks in the fire. Any other comments from Steve or Lauren before we go ahead, Steve.
Yeah, I mean, that's a vexing problem for sure. One of the things that I find encouraging is the conversations we're having that are bringing more community-based approaches to what it is we do and how it is we research. I know this is easy to say, but the citizen science approach is one way to have sort of non-traditional data collection efforts feed into what we're doing. And it's a far cry from underwriting someone to be a lab assistant or whatever, which I think was really sort of the nature of the question. But I think if we broaden our notion of what constitutes real science, we might find that there's more out there to take advantage of than we have been.
Okay, we have another question, and it's specifically for Lauren. So Haley Wright is asking if you have any tips for writing meaningful vision statements for like internal branches or offices.
Yeah, sort of. If you're on the right track, because you really it should be lofty. It should be a lofty where you want to be, and so if you feel like it's a little bit too out there and too much into the future or not attainable, that's where you want to be. You want a vision that is an ideal future state. And there's tons of strategic planning and vision statement writing stuff online. Greg Erickson was actually my mentor with strategic planning stuff. So he had a lot of great input, but I would just look at videos online.
Okay. So we have another question that I really want to get to. This is from Arthur Barros, and he says, I really like my job as an ES, and I don't really want to advance to a senior ES position. Am I harming my career by sitting in one place as long as possible? And I think I want to answer this one before I let anyone else go, selfishly, because I think not. I mean, it's a lot of what I think you were hearing from the comments in Denise's talk that, there is not one career choice for everyone. Everybody is an individual, and what works for you works for you. And if you stay in an ES position for many, many years and then later decide that you do want to promote, there are folks out there that will help mentor you through that process and help you get through to the next step. I honestly, personally, don't believe it's a discredit to anyone for staying in a single position for a long time. I don't know. Others have any opinions?
I would just add on that, to bring it back to the basketball analogy, if you know your role and you do it well, then, and that's your contribution to the IEP science community, then, you're a valued player and you don't need to do something that you're not comfortable with or whatever.
Absolutely. Any other words of wisdom from our panel? Because we're riding right up against our time limit here. And I'm not sure that we can get to the next question, but okay, I'm going to shoot for it just real quickly. One more question for Lauren, coming from Karin Alstad. Have you thought about how you could better engage your community of origin or encourage other young folks to see their own role in environmental stewardship?
Yeah, this is where I really applaud some of DWR's efforts with reaching out to elementary schools in the Rio Vista area, because I think that's where we need to be. We need to be, doing career days and some more public outreach to our youth and just expose them to what careers could look like, what outside careers can look like. And I think getting kids at the age where they're really curious and just exposure. I'm doing a career day at my daughter's school in a couple of weeks. So I would encourage everyone to do the career days at your kids' schools and your nieces and nephews' schools, and as much as possible. But I would like to see more IEP outreach in general too.
Okay, well, with that, we are at our time limit. So thank you to everyone that spoke this morning and for all the good questions that came in from folks that were participating. We're going to take a 10-minute break and we'll be right back with the next session. Thanks.